Welcome back, ladies and gentlemen. This is chapter 3.3. We're graphing using intercepts. And in this set of videos, you're going to be able to find the x and y intercepts of a linear equation. And you're also going to be able to use the intercepts to graph a linear equation. So we're going to find the intercepts, and then we're going to talk about how to use them to graph something. So a couple of quick definitions here first. We have the x-intercept. Now this is not just for a line, by the way. This is for all things, no matter what kind of graph we're talking about here. The x-intercept is the point right there where it crosses the x-axis. So a line, that would be an x-intercept right there, or let's say I had a different type of graph, something like this. This would be two different x-intercepts, okay? So the x-intercept is where the graph crosses the y-axis. We find it by substituting in 0 for the y-coordinate. All right, that's going to be big. We'll explain that a little bit more in the next slide. The y-coordinate of a point, or the y-intercept, is the y-coordinate of a point where the graph crosses the y-axis. So again, if I have a line, it's this one right there. Or if I have the curve like I had on that other one, it's right here, right? It is the point where the y crosses the y-axis. And again, this is found by substituting in 0 for the x-coordinate, okay? Finally, our last one here is standard form. This is a type of linear equation. You will see that it is in this very specific way. We have a times x plus b times y equals c. Anytime we see anything in this format, where a, b, and c are just numbers, like 3x plus 4y equals 10, right? That is called a standard form equation. All right, so let's put some of this to use here. We're going to find the x and y intercepts for this particular equation. Now, I want to draw attention to the fact here that if we had a line, and it might be a different line. This is not this line over here. But if we had a line, we're looking for this point. Well, this point is going to be 0, something, right? 0, y. I don't know what value this is because I haven't marked the graph at all, but it's 0, something. Notice that the x value is 0. Over here, like this point right here is also 0, y. I don't know what the y value is, but I know that the x value is 0. And as it turns out, everywhere on this vertical line on the y-axis, the x value is 0. The x value will always be 0 on the y-axis, which means if I need to find the y-intercept, we're going to plug in 0 for x. Because everywhere on this vertical line, the x value is 0 and the y value is unknown. So if I plug in 0 for my x value, I will always find the value that when it crosses the y-axis. So this is 0 plus 7y equals 28, or 7y equals 28, which I divide both sides by 7. And I'm doing the solving pretty fast because, we've done a lot of solving at this point. And so y equals 4. So here, there is a point, 0, 4, right? When x is 0, y is 4. So that's my y-intercept. But what about my x-intercept, right? What about my x-intercept? Let's look at this thing on the graph over here. When we're finding the x-intercept, we're looking for where it crosses the x-axis. Well, on the x-axis, this point right here is x, because I don't know what it is, 0. The y value here is 0. Right here, this value is x, 0. I don't know the x value, because it's something negative, but I know that the y value is 0. It's 0. It's 0, 0, 0. All of these points are some x, 0. In other words, to find the x-intercept, I plug in 0 for y. So what I get is 2x plus 7 times 0 equals 28, or 2x equals 28. Dividing both sides by 2, I get x equals 14. So my x-intercept is 14, 0. My y-intercept is 0, 4. My x-intercept is 14, 0. I have found the 2 points where it crosses the x-axis and the y-axis. I've got some practice for you on this on your canvas, so please go do that problem, and then I will see you in the next video.